Good morning. Today we are going to start the next topic, which is exponential and logarithmic functions. As we are already aware that an exponential function is of the form a raised power of x. So if we know that a raised by x equal to b, this implies and is implied by log of b to the base a is equal to x, and so we can see that the exponential and the logarithmic functions are inverse of one another. Now we are going to take up another kind of exponential function, which is defined as e raised to the power of x. It is the series expansion, which is 1 plus 1 upon 1 factorial plus 1 plus x upon 1 factorial plus x square over 2 factorial plus x cube over 3 factorial plus so on. This is the series expansion of e raised to power of x, and this is called as natural exponential function. Natural exponential function, where the value of e is given as 1 plus 1 over 1 factorial, 1 over 2 factorial plus 1 over 3 factorial plus so on, which is approximately equal to 2.7, because see, this is 1 plus 1 2 plus 0.5 2.5 like this, and then the remaining amounts to almost 0.2 or so. So it is approximately equal to 2.7. Now this is called as natural exponential function. So when we write log in this form, that becomes that is called as natural logarithm. So if I say, if e raised power of x equal to, let's say, b, then this implies and is implied by log of b to the base e is x, and this function is called as, where log b to the base e is called natural logarithmic function. Okay, so now we are going to consider these functions and do the derivatives of them. So the next theorem says that the derivative, so first of all we are going to do the derivatives of exponential and logarithmic functions. Logarithmic functions. Now here, unless and until specified, we will be dealing with natural exponential function and natural logarithmic function. So the derivative of d by dx of e raised power of x, which is the natural exponential function, is defined to be e raised by x, and d by dx of log x to the base e is defined as 1 upon x. These are the two results which we are going to take, and based on this we will be doing the next exercise. But before that, before proceeding to the exercise, we will just quickly discuss the various laws of logarithms. Now we know that log helps us to convert a product into sum, quotient into difference, and exponent into product. Okay, and we know we have the various laws, as suppose we have log of xy. Now unless and until specified, we will be taking natural log only, so either we write this or simply log xy. If I write log xy, that means the base is e. Otherwise we will be mentioning the base. So let's quickly do a quick recap of the laws of logarithms which we did last year. First is that log of 1 to any base is always equal to 0. This is the first law. Second one is log of a to the same base is always equal to 1. Third one is log of mn to the base a is equal to log of m to the base a plus log of n to the base a. Fourth is log of m upon n to the base a is log m to the base a minus log n to the base a. The next one is log of m to the power n and the base is a is equal to n log m to the base a. The same results get extended to natural log or any log for that matter. You can change the base or you can change the base and write the results accordingly. Now there is another result, that is change of base result. In that what we have is log of m to the base a can be written as, you can change the base. So what we do is you write log m upon log a and you write any base, let's say b you are writing. So this is something constant and here we have managed to change the base. So log of m to the base b is equal to log of m to the base a, and this goes here into log of a to the base b. So using these results, let us now start with the next exercise, which is exercise 5.4. Now all the questions we will be using the standard results of derivatives, which are derivative of addition, subtraction, product rule, the quotient rule and the chain rule, as well as the results for the derivative of exponential function e raised by x and the logarithmic function log x. So let's take a simple example. Let me take question number 2. Question number 1 is very simple. You simply have to apply the quotient rule, that you can try yourself. Question number 2 we have, let's call y equal to e raised by sine inverse x. Clearly we can see it's a function of a function, so we'll have to apply chain rule. So applying chain rule, we get dy by dx equal to, first of all the function is, the outermost function is exponential function e raised by x. E raised by something, the derivative is the same. So you write it as e raised by sine inverse x into, now you come across sine inverse, the derivative of sine inverse is 1 upon under root of 1 minus x square, and so the result becomes e raised by sine inverse x upon under root of 1 minus x square. Same way the third question can be done. Now let me take up the fourth question. The fourth question says that y equal to sine of tan inverse e raised power of minus x. Now here again, now we have to differentiate with respect to x. So again you have to apply chain rule to get the result. We get dy by dx is equal to, now the outermost function is sine, derivative of sine is cos, and the whole thing gets copied down as it is. Then into, then you come across tan inverse, derivative of tan inverse is 1 upon 1 plus x square. Now here in place of x you have e raised power of minus x, so this square into, now you come across e raised power something, derivative of that is e raised power that, into, you come across minus x, the derivative of minus x is minus 1. So, you get dy by dx, you just rearrange, it becomes minus e raised power minus x cos of tan inverse e raised power minus x whole upon 1 plus e raised power minus 2x, which is the result. Same way you can try the other questions also. So, let us take one more question. Let us take question number 5. Now, in question number 5, we have y is equal to log of cos of e raised power of x. Again, it is a function of a function of a function. So, again applying chain rule, we get dy by dx equal to, first of all, derivative of log is 1 upon that function. So, cos of e raised power of x into, then we come across cos, derivative of cos is minus sine e raised power of x. Then we come across e raised power x, derivative is e raised power x. So, derivative becomes dy over dx is equal to minus e raised power x sine of e raised power x whole upon cos of e raised power of x. Now, let us try one more question. Let us take question number 7, or let us take 6 also. Now, here y is equal to e raised power x, e raised power of x square, and so on, e raised power of x raised power of 5. Okay. So, again applying chain rule plus the law of addition. So, you get dy by dx equal to derivative of this plus derivative of this plus derivative of so on and so forth. So, derivative of this is e raised power x plus derivative of this is e raised power x square into derivative of x square is 2x. Same way it will be e raised power of x cube into 3x square plus e raised power x4 into 4x cube plus e raised power of x5 into 5x raised power of 4. And so, you get dy by dx is equal to e raised power x plus 2x e raised power x square, 3x square e raised power x cube plus 4x cube e raised power of x4 plus 5x4 e raised power of x5, and this is the answer. Same way you can try the rest of the questions also. Now, let us take one more. I will just take question number 8 also, and the remaining you can try yourself. Y equal to log of x. Again, it's a function of a function. So, dy by dx, again we will be applying chain rule. We get, first of all, derivative of log is 1 upon, so it gets carried down like this, into, you come again, you come across log x, which is 1 upon x, and so the answer is x log x. Now, one last question, that is question number 10. Y equal to cos of log x plus e raised power of x. So, dy by dx is, now first of all you come across cos, derivative is minus sine log x plus e raised power of x into, now you come across this whole thing. So, derivative of log x is 1 upon x plus derivative of e raised power x is e raised power of x, and so dy by dx is equal to minus 1 upon x plus e raised power x sine of log x plus e raised power x. So with this we finish exercise 5.4. We have 2-3 questions which are left out. Please try it and complete this exercise. Thank you.